Now we're going to learn the derivatives of all of the trig functions. So we're going to start off with sine of x, and I'll show you why the derivative of sine is cosine. And then I'll give the rest of them to you. And again, these are 6 things that you want to memorize. I know this unit has a lot that you need to memorize, but knowing all of these pieces are going to make the rest of the course much more natural. So we want to show that the derivative of sine of x is equal to cosine of x. So if we want to find the derivative of sine of x, we need to find the limit as h goes to 0 of sine of x plus h minus sine of x all over h. So the first thing we're going to do is use one of our trig identities that you would have learned in pre-calc to find, to write out sine of x plus h. So sine of x plus h, well first we'll write this limit as h goes to 0. Sine of x plus h is equal to sine of x cosine of h plus cosine of x sine of h. And then we're subtracting sine of x, and this is all over h. Okay, now we're going to rearrange this to help us out. We're going to put the sine of x stuff next to each other. So we have sine of x cosine of h, and then we have that minus sine of x at the very end, and then we have plus cosine of x sine of h all over h, and I'm going to pull out the sine of x. So here we'd have cosine of h minus 1 plus cosine of x sine of h all over h. Now we're actually going to break this into 2 limits because we can break this into 2 fractions where they're both over h. So we're going to write this as the limit as h goes to 0 of sine of x times the cosine of h minus 1 over h plus the limit as h goes to 0 of cosine of x sine of h over h. Now you'll notice the only pieces that have h in them will be this one and this. So we're actually going to help use our calculator to help figure out the limits of those red pieces. So if we look at cosine, we're going to do cosine of x, and I need to start parentheses, cosine of x minus 1, this all over x. Okay, and we're looking as x goes to 0. I know there are h's in the sheet, but I don't have an h button on my calculator. And I also want to make sure I'm in radians, which I am. Okay, so if we look at this graph, okay, we can see as we go to 0, the y value, the limit there is 0. So this one right here, the limit's 0. So limit of sine of x times 0, we just get 0. Now we want to look at sine of x over x for that second red piece. And if we look there as the limit goes to 0, you'll actually see the limit is up at 1. So this is equal to 1. So it's equal to cosine of x times 1. So our final limit, our derivative, is equal to cosine of x. Now you can do something very, very similar to show that the derivative of cosine of x is equal to negative sine of x. Now the next one I want to show you is how we can use the quotient rule to find the derivative of tangent of x. Well, we know tangent of x is equal to sine of x over cosine of x. So if we want to find the derivative, of tangent of x, we're taking the derivative of sine of x over cosine of x, which will need the quotient rule. So for the quotient rule, do low, d high, the derivative of sine of x we've just talked about is cosine of x, minus high d low, so the derivative of cosine of x is negative sine of x, all over low squared, so all over cosine squared of x. Now this numerator, we'd have cosine squared of x for cosine times cosine, and then we have a negative sine of x times a negative sine of x, so we get plus sine squared of x, all over cosine squared of x. Now remember, one of our Pythagorean identities for the trig functions is that cosine squared of x plus sine squared of x is equal to 1. So this is equal to 1 over cosine squared of x. And if you remember, 1 over cosine is secant, so 1 over cosine squared would be secant squared of x. So the derivative of tangent of x is secant squared of x. Okay, so here in your notes you have a table with the derivative of all 6 trig functions. And so, you know, the derivative of sine is cosine, the derivative of cosine is negative sine of x, the derivative of tangent, like we just showed, was secant squared, the derivative of cosecant is negative cosecant of x cotangent of x, the derivative of secant of x is secant of x tangent of x, and the derivative of cotangent of x is negative cosecant squared of x.